like when we were doing system of equations and we talked about solving systems by graphing, and then we did elimination, and then we did substitution. We kind of went through the different methods. We're going to talk about solving quadratic equations now, and we're going to kind of work through the different methods. Method number one, kind of like it was with our systems situation, is that we're going to solve by graphing. And again, I want to show you how to do it by hand, but we're going to switch over and make sure we know how to do it on Desmos as well. So when you get a second, grab a Chromebook. All right, so one method to finding the roots or solutions of a quadratic equation is by finding the x-intercepts. So sometimes we call our answers solutions, sometimes we call them roots. So just beware that both of those words mean the same thing. They're synonyms with each other. Another word that we sometimes use is zeros. So roots, solutions, zeros. Or we can even call them x-intercepts. When you go to solve, your solutions live on the x-axis. So wherever your graph touches the x-axis is where your solutions are. So there are different situations that can happen. Situation number one, you could have two solutions. You have two solutions when you have two x-intercepts. So again, your solutions are your x-intercepts. So if you have two x-intercepts, you have two solutions. They go hand in hand. You could also have one solution, and that would be when your vertex lives right on the x-axis. Do you see how for that one it only touches once? So one solution is an option. The other thing that could happen is you could have a graph that opens in such a way that it doesn't touch the x-axis at all. So you could have a graph up over here, and because it opens up and continues up, it wouldn't touch the x-axis at all. So these are the three different things that you could have that could happen. So we got to make sure we think through all the possibilities, and these are all the possibilities. So again, today when you're solving stuff, you should get one solution, no solutions, or two, and we're going to explore those. Some of the questions are literally this easy, it's almost like they're trying to trick you. They give you the equation, they give you the graph, and they say find the solutions. Again, the solutions are your x-intercepts. So literally, I'm going to look and see where my x-intercepts are. So I have an x-intercept at 1, 2, 3, 4. So one of my solutions is 4. My other solution is -1. And again, why are these solutions? If you take these numbers and plug them in, it's going to give you 0. So we're looking for things that make it 0. So if I plugged in 4, this side would 0 out. If I plug in -1, this side would 0 out.
Do you put positive numbers in the front?
It doesn't matter.
Okay.
Yep, I'm not going to be picky on the order here. And so these are my two solutions. I'm going to box them in. Could you put them in numerical order and do the -1 first? Sure. Could you even write -1 or 4? You could write that too. We're not going to write and though, because can x be two things at the same time? No. So the word or is what we're going to use if we want to insert a word in there. Okay, next one. We're going to go through our graphing process like what we did in section 3.1. We're going to graph it and we're going to find our solutions that way for the first one. Again, we're going to move into Desmos, but not quite yet. Look at this beautiful graph. It's just amazing, isn't it? Let's add an x-axis. So here's x, here's y. Let's make that a little bit better. All right, so I have a quadratic equation. Remember, we would pick out our a's, b's, and c's. What's a? 1. What's b?
2,
What's c?
2,
1. Okay, so remember that our first part of graphing a quadratic equation is to find the vertex. And remember, to find the vertex, we do that -b over 2a business. So -b would be -2 over 2 times a, 2 times 1. What is negative 2 divided by 2? Negative 2 divided by 2. Negative 1. Okay, so that's the x-coordinate of my vertex. I want to find what's on both sides. Remember, we want to look at both sides and see what's going on. So I'm going to figure out 0 and I'm going to figure out negative 2. How do I figure out, let's start with negative 1. How can I figure out the y value that goes with it? Yeah, plug it in. And remember, when we plug it in a nice little parenthesis house. So I'm going to plug it in like this. I'm going to get negative 1 squared plus 2 times negative 1 plus 1. So this is going to give me my value that goes here. So I'm going to do it. You guys do it. Make sure you know how to type it into your calculator. Again, calculators are great, but if you don't know how to use them, it doesn't matter that you have one. So make sure you know. Okay, ready? Oh, you can't even see my screen. Are you ready? Drum roll. Did you get 0? Okay. All right, now, zeros I can plug in, even on a Friday morning. 0 squared is?
0.
Plus 2 times 0? Plus 1? 1. What do we know about this y value? It's also 1, right? Because it's symmetric, so it's going to be the same. So let's graph our points. We have a point at negative 1, 0. We have a point at negative 2, positive 1. We have a point at 0, 1. And I'm going to draw in my U-shaped graph. So remember, give them some curvature. These are all U-shaped graphs. How many solutions do I have and where does it live? Ooh, I gave away the answer with how I worded myself. How many solutions? Let's start with that. 1. We have 1 solution. And what would I say? My solution lives where? Negative 1. So again, you're giving that coordinate. That's all you're doing for that one. How do we feel about that one, okay? Flip the page when you're ready. So there are a couple other types of problems that you could be asked to do. Number 2 is pretty easy. So it says, figure out where the roots, so remember roots, zeros, solutions, x-intercepts all mean the same thing. It says, figure out between which integers they live. All right, here's what that means. If you look right here, do you see how we go from 16 down to negative 2? Okay, so if my graph, if I had a point at negative 7, positive 16, so up here somewhere, and then I had a point at negative 5, negative 2, what happened in between those 2 points? What did I have? It would have crossed what? Yeah, it would have crossed the x-axis, so I would have had an x-intercept, which again is the same as a solution. So somewhere in here, I don't know exactly where, but somewhere in there I had to cross if my signs switch. So I was in positive land and I went to negative land. In order to get from one to the other, I have to cross the x-axis. It's a must, okay? So this one just says between what integers, integers are numbers, positive or negative numbers, not fractions, between what consecutive integers does the 0 live? So do you see how I have a 0 that lives between negative 7 and 5? So that's what I'm going to write. Between negative 7 and negative 5, I had a 0. Again, how do I know? Because I went positive to negative. There should be one more 0. What does it live in between? In terms of x. Always giving our answers in terms of x. So look where you've got another sign change. Because if you're going from negative to positive land. Go ahead.
1 and negative 8.
Yeah. So we've got, so 1 and negative 8 is where we switch and go up. So it would be in between 1 and 3. So we always write our answer in terms of x. So in terms of x, in between 1 and 3, there was a solution. Where was it exactly? I don't know, and this question doesn't ask me. You see how it just says between which ones? So again, you're going to look for a sign change for those. All right, the last two are the same type of problem, and this is where we're going to use Desmos. Does anybody have any questions on what we've done before so far before we switch over to Desmos? Are we good? Okay. So let's go to Desmos. Again, either open up a new tab on Google and say Desmos Graphing Calculator, or you can open up in app mode. You can open up Desmos that way, and that's how we'll use it for tests, is app mode only, so I know you're not getting into other things that you shouldn't be in. Okay, hold on. Sometimes I feel like I'm giving these computers a little bit of CPR because I'm like pressing it and pressing. Believe in you. Breathe. Okay. I know, that's what I'm 100 beats a minute. Staying alive, staying alive. Okay. All right, here we go.
Okay, so time to like watch
You could use your app if you wanted to.
Oh yeah, I should have just gone app, shouldn't I? You can't see my
Way
face.
quicker on the cursor.
Yeah, I don't know what I'm doing over here. I don't know
You
what
know,
I'm
you should make your password visible so I can take a picture of it.
Mm-hmm. Oh God, now it's gonna make me do this two-step. No one else is trying to be me.
You can go
Google.
backwards.
Wait, you two-step verification on your Chromebook?
Well, it's the Google. It's trying to log me in. Is it me? Yes, it's me. No one else. No one else wants to graph on Desmos at 9:05 on a Friday morning. It's me. I promise. Can you not tell? Okay. Yeah, I regret my decision for not going to apps, by the way. All right, Desmos Graphing Calculator. And it should be the first, oh, just kidding. There it is. Okay. We got there. It took 5 minutes, but that's okay. All right, it says solve using technology. Are you ready to solve using technology? We're going to type in our equation. So type it in, -2. Oh, no. I don't. Okay, shh, stop it. Where did it go? Okay, there we go. We're back. Maybe. -2. Type in your x. Do you know how to square it?
Yes.
How do you square it? What do you do? Caret key. So I'm going to hit Shift 6. Shift 6 is going to make it go up high. So Shift 6 to get to the exponent spot. Type in a 2. Do you see how I'm done in the exponent spot now? Arrow to the right and it'll come back down. So always arrow to the right, it'll come back. So plus 3x plus 4. All right. Do you see how it gives me the intercepts in gray? Do you see them? Now, if I had been graphing by hand, is there any way I would have guessed this point? No. And how much would you like me as a math teacher if I gave you that one and was like, hey, graph it and find it? You wouldn't like that. It'd be bad. All right, so we're going to go ahead and let's round. I like 2 places after the decimal. So do you see how if I go 2 spots, negative x equals negative 0.85 is one of my solutions. I'll show you how I wrote it in just a second if you're not sure. I'm going to go over here, 2.35. Make sure you round correctly as you give me your answers. Oh, they'll stay? Stop it. Okay. This is why you guys are the technology generation, and I'm old. Yes, they will stay if you click on them. Genius. I judge myself for not knowing that, honestly. Okay, so here's how I wrote my answer. How fast was that? Super fast and easy, right? Okay, one more problem. You ready? A lot of everyday life situations that you encounter are going to be parabolas because of gravity, right? So think about if I throw a ball. If I throw a ball, what shape is it going to make? What shape is it going to make? It's okay to answer me.
Curve.
Curve. It's going to give me a parabola because of gravity. I'm not going to throw a ball and it's not going to go around the world and come back and hit me in the back of the head, right? I'm going to throw it and it's going to go down because of gravity. So this next equation is talking about using gravity, and a lot of situations are like this. All right, this negative 16 is part of your gravitational constant. So that's why that number is already in there. So it says we have a height of an object is in feet. V naught is the initial velocity. So whenever you have a little subscript 0, that usually means it's initial. It's where you're starting. So it's the starting velocity. V naught is the initial velocity in feet per second. T is the time in seconds. H naught, or H sub 0, is the initial height. And we're going to round to get our answer. Okay, so we throw a ball. And I'll pretend like I'm throwing it how I shoot. I still granny shoot when I do. Okay, so I throw a ball. And then the initial velocity upward is 18 feet per second. So this number is going to get plugged in for my initial velocity. So she throws it, but her friend misses the catch, and then the ball hits the ground. All right, well, when she threw the ball, she was holding it, right? And she was 5 feet above the ground, or the ball was, when she had it. So when she threw it, the ball was 5 feet in the air. So 5 feet was the initial height. She wasn't somehow throwing the ball off of the ground. So 5 is going to be my initial height. So this equation is negative 16t squared. Again, that part is for our gravitational constant. Plus the speed of the ball, 18, and that was feet per second, plus the initial height, which was 5. So this is my equation. So you just need to make sure you're plugging the numbers into the right spot. And now our question becomes, use a graphing calculator, or Desmos, and determine how long it'll take until the ball hits the ground. All right, so go to your Chromebooks. I set mine, right here is where I set mine. All right, so I'm going to delete it. You could also leave that first equation and graph a new one, and it'll color code them. That I do know. Let's see, negative 16. Hit shift 6 for your, we don't need the exponent yet. Too soon, Miss Vessel, too soon. We need the x, then we need the squared. Plus 18x plus 5. Okay, so we are standing over here. When does it hit the ground? And it says to round to what? Round to the nearest tenth. So tenth is just one spot after the decimal. So what would I write down? 1.4. So how long did it take for the ball to go up and then hit the ground? It would be 1.4 seconds. And that would be your answer. Now, I want to show you quickly how to type it in if you have a graphing calculator. Does anybody have a graphing calculator out there in the world? Okay, let me show you this really quickly. Quick graphing calculator tutorial. Because again, these are also great usable tools, and so I want you to be able to use this as well. Okay, so if you have a graphing calculator, I'm going to go through what buttons to press for that. So you're going to go to your y equals button first. Do you see the y equals button right here? Press it. Oh my. Look at all the garbage I have in there. I'm going to hit clear. And I'm going to arrow down. I'm going to hit clear until everything's gone. So make sure everything's clear. If it isn't, arrow down. Clear, 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 clear. Okay. Then I want to type it in very similar to how I was typing stuff in a minute ago. Negative 16. We don't have a button that's going to give us a T. It's going to give me an X, and that's okay. Do you see this button right here? That's your variable key. So the key for a variable is the X, T, theta, N button. And that's because sometimes we need different letters depending on what we're working with, which type of equation. So I'm going to put in my X. Remember, you have a fancy squared button right here. You can press that. It's going to square it. Then we have plus 18x. And again, we go back to that variable button. Plus 5. And then we're going to hit graph. Probably the least surprising button that I pressed. Does it look like the same graph as what was on Desmos?
Yeah.
Okay. Now, do you see how we want this point, but I can't like hover over it like I don't have a mouse and a cursor and all the things, right? So, this is the way that you find your zeros on the graphing calculator. You're going to press second trace. Do you see above the word trace is the word calculate? Okay, so that's what we're actually going to. So if you press second, that means you're going to the thing above it. So you're going to second trace, to the blue thing, yes.
Alpha goes to green.
So if you press second trace, you're going to go to calculate. And then we talked a minute ago about the fact that these are called zeros, solutions, x-intercepts, roots. Do you see how the word that your graphing calculator has chose to use is 0? So I'm going to hit enter. Now it says left bound. So I want to find this point right here. I want to see where it lives. So I'm going to go close, but I'm going to go close to it and still be to the left. Do you see how if I think about this x-intercept, if I drew a vertical line through it, that blinky cursor would still be off to the left a little? So I hit enter. It's going to say right bound, so now I'm going to go down and to the right. And then it's going to say guess, so I'm going to go kind of close to where the solution is, and I'm going to hit enter. Did I get the same answer? Oh, that's hard to see. Yes is the answer to that if you can't read that. That says 1.4 if we round to the nearest tenth. So this is giving me the same answer. If you need more help with that, I can walk you through it again on the graphing calculator. That's just kind of the quick version. And then these are the buttons you press. The left bound, right bound sometimes gets a little tricky. So again, if that's something you need help with, make sure you ask me. All right, I'm going to stop this.